Welcome to another lecture of my machine learning playlist. Today we are going to learn about linear regression. So up to now we have learned already the PLA, that is perceptron learning model. There we were classifying our data into two parts, that is a good customer and bad customer. But now we are going to predict data, okay, or predict the particular value. Suppose there is a system where the temperature of a certain day is given and we are going to predict the rainfall of that day based on the temperature value. Okay, so we are going to predict a particular value of the rainfall. So for that we are going to use the linear regression. So let's see, the variables or the temperatures are given as x1 x2 up to xn, and the predicted rainfall is given as y1 y2 up to yn. Okay, so the training sample is past value, that is the past temperatures and the rainfall corresponding to the temperatures up to n terms. Okay, that is our training sample, or that is our actual values, and we are going to need a hypothesis that will going to predict the rainfall of a day with given temperature, okay, accurately. That is going to be our h of x. Okay, so suppose that is a graph. This is the x, that is the temperature axis, and that is the y, that is the rainfall axis. This linear learning is going to predict our accurate rainfall. So suppose these dots are the data points for a particular day, that is xn. Okay, for a particular day the temperature is xn, and suppose the rainfall of that day is yn, that is our actual rainfall. Okay, yn. So that point is here, but according to our this line, which is going in the approximately middle portion of all the points, so according to this line our rainfall of that day should be this one, that is h of xn, that is our predicted value. So this difference of yn and h of xn is our error. Okay, this is our error in our prediction. So what is the error? We can say the actual value minus the predicted value. So yn minus h of xn. Okay, so that is our error. It can also be negative, so we will take mod or something like that. So we will come to that later. Why the error is so important? Because to make our model perfect, we need what? We want to minimize our error. So if our error is minimized, then we can say that our model or that our function is approximately accurate, almost accurate. Okay, so see what is the solution. First see the solution. This is our one single line, you can say. So our linear solution is going to be h of xn is axn plus b. Okay, h of xn will be axn plus b, because this is a equation of a straight line. You already know that linear equation. Okay, so first we got the value of h action, that is axn plus b, and we already know the actual value yn. So now we got the error. So see, error is what? Error is yn minus h of xn. The yn is the actual value, h of xn is the predicted value, and we are taking mod because this yn can be greater than h of xn or it can be less than h of xn, but in both cases this is the error. If we don't take mod, then the errors are going to cancel out each other. Okay, because there will be positive error and negative error. So we are going to take mod to make sure that the errors does not cancel out each other and we get all the errors correctly. So we can take it like that by giving mod, or we can have another way. We can just have the square of the error. Okay, so if we square any positive or negative value, we are going to get always a positive value. Okay, so there is no chance of cancelling the errors. So why we are doing square? Why we are not taking mod? Because this absolute function or mod function is not a well behaved function, where this square is a well behaved function. So what do we mean by well behaved function? Because it is not differentiable. Okay, we cannot differentiate this absolute value or this mod function, we cannot differentiate it, so we use square. So you might think, why this being differentiable is an important issue? Why we need to differentiate it? Because see, we need what? Our aim is what? Our aim is to minimize the error. And how to find minima or maxima? I think you have already done that in your class 11 12th. To find the minimum value or to make a equation minima, we need to differentiate that equation, and the differentiated value will be equals to 0 for a particular minima or maxima. Okay, so we are going to find it minima here, so we need to differentiate the equation. So the equation must be differentiable. That's why we are using the square value. Okay, that's why we are using the square. So we are squaring the error. So if the error is negative or positive, after getting squared, it is always going to be positive. And we are taking summation of the errors from all points from n equals to 1 to capital N. So this is our total error. Okay, now for we get the total error, that is from n equals to 1 to capital N, yn minus h of xn, that whole square. This yn is the actual value, h of xn is the predicted value, and this summation is for all points. And now this 1 by capital N is, this n is the number of data points, so that is the total error, and that is the total number of data points. So that means this whole thing is the average error, or we can say mean error. So we are having square function here for calculating the error, so we can say this as mean square error also. Okay, we can say this MSE or mean square error. So we can write it like this: E equals to 1 by capital N, that is n is number of data points, and the summation of n equals to 1 to capital N, yn minus axn minus b, that whole square of that thing. Okay, so where that axn minus b comes from, see, I have already written in my previous page that h of xn is what? It is axn plus b. That is the formula of a linear equation. Okay, it is a linear equation. That's how we write a linear equation, and our function is a linear function. We already know that, so that's why I have written it like axn plus b. So the negative of axn plus b will become minus axn minus b. So yn minus axn minus b, that whole square. Our aim is to minimize the error and find the value of a and b, because these are the terms we need to find the value, because x and y will be given in our system. Okay, value of x will be given to us, and we are going to calculate the value of y. So we are only two unknown terms we have here, that is a and b. So that's we need to find. So for which value of a and b this error is going to always be minimum. Okay, so for that we need to differentiate this total or the mean square error. Okay, so the error is written as e, so we will going to differentiate it with respect to a, and we are going to differentiate with respect to b, and the differentiation will be equals to 0 because the derivative is equals to 0 at only the maxima or the minima point. Okay, so de by da will be equals to 0, and de by db will also be equals to 0. So now let's do de by da. So see, dda of the error 1 by n, that is 1 by n equals to 1 to capital N, and this whole thing. Okay, so now that partial differentiation we are going to do. So this in 1 by n is coming outside, and this whole summation thing is here, n equals to 1 by n, and here the differentiation is we are doing, this 2 comes here, and the whole thing is after that, and the differentiation of this particular part minus axn will be going to minus of xn. Okay, this we are going to multiply after that. So this whole thing will be equals to 0 because this is our minimum point. Now let's solve it. So see, this is going to remain same, 1 by capital N. We are going to multiply the whole thing with 1 by capital N into summation of n equals to 1 to capital N. So see, this first multiply this x and yn, so it will going to become, so this 2 and this negative is going to omit with this 0. Okay, we are going to neglect this. So this xn and yn become x and yn. So 1 by capital N, n equals to 1 to capital N, x and yn. Okay, this is going to be our every terms will be multiplied by this thing. Then here again axn square. So a is remaining outside, a by capital N, and the summation is going to become n equals to 1 to capital N xn square. And again here we have what? We have b by capital N and xn, n equals to 1 to capital N xn. Okay, so that is the whole 1 by capital N into summation of n equals to 1 to n is going to be multiplied with every term, and this whole thing is equal to 0 as always. So we can write this 1 by capital N, n equals to 1 to capital N x and yn as xy bar. Okay, that is we are having the mean value, or you can say the mean value of this. Okay, because we are having the sum total and dividing it with number of data points. So that is xy bar, and for this part it will be x square bar. A is remaining same, but this divided by 1 by n is going to be part of this, so it will become x square, a x square bar, and this is going to become bx x bar. Okay, so see, xy whole bar, this is xy whole bar, this is a and x square bar, and this is b x bar. Okay, and this whole thing is equals to 0. Suppose this equation is number 4. I hope you understand how these things is coming. Now let's do the next thing, that is dE by dB equals to 0. So now let's differentiate dE by dB. So what was the value of error? This is our error. Now we are partially differentiating with respect to b, and what we get the similar kind of thing, that is this 2 is coming forwards, and after we were having one minus xn value for here, because the a was multiplied with xn, but here this b is alone, so there we are not going to have any minus b or something like that. We are just going to have 2 into this whole thing. Now let's multiply the every part of the equation with 1 by n, and some n equals to 1 to n summation this thing. So see what we have, 1 by n equals to 1 to capital N yn minus a of capital N, again similar thing, a of capital N equals to 1 to capital N xn, and minus having n number of b's, so it will become b capital N, and we are dividing this again with 1 by capital N, so it will be bn by n. Okay, so for summation of n equals to 1 to capital N b, it means what, we have n times we are having b, so it will become nb, and we are dividing this whole thing by capital N, so it will become b capital N by capital N. Okay, so this n will going to be omitted, and what we have now 1 by capital N equals to 1 to capital N yn. So this thing I have already shown you, this will become y bar, and this will become a x bar. Okay, and this is going to become minus b. So we have y bar minus ax bar minus b equals to 0. So we have two equations, that is equation 4 and equation 5. So now if we going to solve these two equations to have the value of a or value of b, so let's see. So see, these are the equations we got after solving. Okay, xy bar minus ax square bar minus bx bar equals to 0, that is the equation 4, and y bar minus ax bar minus b equals to 0, that is equation 5. So now let's solve this, multiply 4 equation with 1 and 5th equation with x bar, and then subtract them. We get what? We get xy bar minus ax square bar minus bx bar, minus we are multiplying this also with x bar and then subtracting. So we have what? X bar y bar minus ax bar the whole square and minus bx bar. Okay, equals to 0, it will be equals to 0. So now let's see, we have what? We have xy bar and minus x bar y bar. We have minus ax square bar plus a x bar the whole square, and this minus bx bar plus bx bar will get cancelled out, and it will be equals to 0. So now let's have the a part on one side, and the value will become xy in whole bar minus x by y bar equals to a of x square bar minus ax bar whole square. Okay, so the value of a will become xy whole bar minus x bar y bar x square bar minus x bar whole square. This is the value of a we are going to get. Okay, so this particular thing on the numerator is the covariance of x and y, and the denominator is variance of x. Okay, so we can say a is equals to covariance of xy divided by variance of x, and from the equation y equals to ax plus b, we can write that y bar is equals to ax bar plus b. Okay, we can write y bar equals to ax bar plus b. Now let's do my equation 1 minus equation 5. So this is the equation 1, y equals to ax plus b, and this is the equation 5 that we got. This is the equation 5. Okay, this is the equation 5, y bar equals to ax bar minus b. So we are doing y minus 5, we got what? We got y minus y bar equals to a of x minus x bar. Okay, so for a given x equals to x star, the rainfall of y star will be what? So suppose a value of a particular day's heat x is given as x star. So we are going to calculate the rainfall of that particular day, that is the y star. That will be what? That will be y star minus y bar equals to a of x star minus x bar. We are getting that from this equation. So the y star will become y bar plus a of x star minus x bar from equation 6. What is the equation 6? That is a equals to covariance of x comma y divided by variance of x. So we can say covariance of x comma y divided by sigma x square, or we can, from here we can also write covariance of x comma y by sigma x sigma y into sigma y by sigma x. Okay, we can write that because sigma y sigma will get cancelled out and this will become sigma x square. So we are going to get this one already. Okay, so we can now make it like that. This whole part is what? This whole part is correlation coefficient. Okay, correlation coefficient, or we can write rho of x comma y and into sigma y by sigma x. So we can also write this as regression coefficient 2. So now let's see, we can convert any non-linear model to a linear model of more parameters. So here we were getting a linear model. Okay, here we are getting a linear model of a particular one parameter. But what will happen when we are going to get a non-linear model? Suppose the graph is here, what the graph we get is like this, but suppose we get a graph like this, then what will happen? Okay, suppose we have like equation like this, h of x equals to ax square plus bx plus c. So this is not a linear equation. So how can we solve this type of equation? By linear regression. So we can always convert a non-linear model with to a linear model of more variables or more parameters. How can we do that? We are just going to replace this x square as z1 and this x as z2. So see, now we have az1 plus bz2 plus c. This is also a linear model. Okay, this z1's value is x square and z2's value is x, but we are replacing this, so we are always having one linear model. So now we can also solve this with linear regression.